Hi there, welcome to my channel Tech Recaps. Today, I'm going to give a brief recap of the technology. Lidar, which stands for light detection and ranging, is a remote sensing technology that uses laser light to measure distances with high precision. Detection and ranging of lidar light. Lidar is a remote sensing technique that employs lasers to determine elevation of objects such as ground, forests and buildings. To detect objects, lidar employs an ultraviolet visible or near-infrared source. Light energy released by a lidar system is known as pulse light, while light energy reflected off the ground or an object is known as return light. This means that the lidar system sends a light pulse and then waits for the pulse to return. It determines the varying distance of the objects by measuring how long it takes for the transmitted pulse to return to the sensor. Actually, this is where the name lidar comes from, light detection and range. Whereas sonar utilizes sound waves to map things, radar employs radio signals. A lidar, on the other hand, makes use of laser-generated light. As the plane travels, a lidar instrument scans the ground from side to side. As a result, while some pulses will travel directly at nadir or in a straight line, most pulses will travel at an angle. Airplanes. The most widely used platforms for collecting lidar data over large areas are unmanned aerial vehicles and helicopters. The various methods for collecting data with lidar from the ground, flare, or satellite. Lidar comes in three varieties. Lidar topographic. It normally employs near-infrared light to map the land, while metric lidar uses water-penetrating green light to determine seafloor and river bed elevations. Terrestrial lidar is effective for mapping buildings, natural features, and trees at ground level, and it is also valuable for creating 3D models of heritage sites. An aerial lidar is made up of four elements that work together to detect and range light. As the plane flies, lidar sensors scan the ground from side to side with a pulsed laser beam. The sensor features a detector for sensing the returns from objects. GPS receivers track the airplane's altitude and location. These factors are critical for obtaining correct terrain elevation values. Elevation calculation uses orientation to precisely determine the real position of the pulse on the ground. Computers capture all of the height information. Inertial measurement units or IMU track the orientation and speed of the airplane as it flies. As the lidar scans the surface, these four components of the lidar system work together to produce highly accurate and usable results. Lidar is used for wide area mapping, coastal changes, floodplain mapping, and engineering applications such as mapping bridges and roads. Continue watching my video as we will continue to explore more on newest technology today. Don't forget to subscribe, like, comment, and share.